Have you ever wondered what weapon dominated ancient Chinese battlefields for over 2,000 years? It wasn't the sword, nor the spear. It was a marvel of engineering, a silent killer that could pierce armor from a distance, the crossbow. Today, we're diving deep into the fascinating history and brilliant mechanics of the ancient Chinese crossbow. The story begins in the spring and autumn period, around the 6th century BC. While simple crossbows might have existed earlier, this is when they truly started to shine. Imagine being a soldier back then. Your enemy has a regular bow, needing immense strength to draw and hold. But you have a crossbow. You can preload it, take your time to aim, and release a bolt with devastating power, all with less physical strain. This was a game changer. Early crossbows were made of wood or composite materials, but the real innovation was the trigger mechanism, typically crafted from bronze. This small, intricate device is what made the Chinese crossbow so special. It allowed for a smooth, reliable release, far superior to the simpler, cruder designs seen elsewhere. As we move into the Warring States period, the crossbow's role exploded. States like Chu and Han became famous for their crossbow armies. It was no longer just a specialist weapon. It was the backbone of entire military forces. The famous strategist Sun Tzu, in his Art of War, mentioned the crossbow's strategic importance, emphasizing its ability to create a deadly rain of arrows on the enemy. Archaeologists have unearthed incredible examples from this era, complete with intricate bronze trigger mechanisms that still function today, a testament to the incredible craftsmanship of the time. These triggers were sophisticated, often composed of 3 interlocking pieces: the nut that held the string, the sear that held the nut in place, and the trigger itself. When the trigger was pulled, it caused a chain reaction, releasing the nut and the string with incredible precision. Then came the Han Dynasty, the golden age of the Chinese crossbow. The Han military refined the crossbow to an art form. They developed standardized, mass-produced models, ensuring that every soldier in their vast armies was equipped with a reliable and powerful weapon. This was industrial-scale warfare in the ancient world. They created different sizes for different purposes. There were lightweight handheld crossbows for cavalry and infantry, allowing for mobility and rapid firing. But there were also massive siege crossbows, called bed crossbows or jiao che nu. These were gigantic weapons mounted on frames, sometimes needing several men to winch back the string. They could fire huge spear-like bolts that could shatter fortifications and skewer multiple soldiers at once. It's like comparing a handgun to a piece of artillery. Both are deadly, but on completely different scales. The Han Dynasty's military success, particularly against the nomadic Xiongnu tribes to the north, owed a great deal to their mastery of crossbow tactics. They would use formations of crossbowmen to lay down a withering field of fire, breaking enemy charges before they even got close. But how did they achieve such power? The secret lies in the mechanics. Unlike a regular bow, where the archer's strength limits the draw weight, a crossbow uses a mechanical system. Early crossbows were drawn by hand and foot. A soldier would place the crossbow on the ground, put their feet on the bow's arms, and use their back and arm muscles to pull the string up to the locking mechanism. This simple leverage allowed them to handle draw weights far exceeding what was possible with a hand bow. This meant the bolts flew faster, farther, and hit harder, easily punching through the armor of the day. As technology advanced, so did the spanning or drawing methods. During the Han and later dynasties, the windlass and crenequin were introduced for the larger crossbows. The windlass was a crank and gear system that made it possible for just 1 or 2 men to draw incredibly powerful siege crossbows. Imagine turning a small crank to winch back a string holding hundreds, even thousands of pounds of tension. This mechanical advantage was the key to their immense power. The precision of the bronze trigger mechanism ensured that all this stored energy was released efficiently and safely. It was a perfect marriage of powerful materials and intelligent design. Perhaps the most legendary innovation in Chinese crossbow history is the repeating crossbow, the Zhuge Nu, famously associated with the brilliant strategist Zhuge Liang from the Three Kingdoms period. While it likely predates him, he is credited with greatly improving its design. This was the ancient world's assault rifle. It featured a top-mounted magazine that held about 10 to 12 bolts. The operator would use a single lever action to both span the bow and load a new bolt. By pushing the lever forward, the string was caught. Pulling it back drew the string, dropped a bolt into the firing groove, and then fired it. This allowed for an incredible rate of fire. A trained user could empty the magazine in a matter of seconds. Now, the repeating crossbow wasn't as powerful as its single-shot cousins. Its smaller size and rapid-fire mechanism meant it had a shorter range and less penetrating power. It was more of a close-quarters weapon, perfect for defending city walls or ambushes, where the sheer volume of projectiles could overwhelm an enemy. Imagine a wall of defenders, each firing 10 bolts in 15 seconds. The psychological impact alone would be terrifying. The crossbow's influence continued for centuries, through the Tang, Song, and Ming dynasties. The Song dynasty, in particular, faced constant threats from northern cavalry armies and relied heavily on massive formations of crossbowmen to counter them. They developed new tactics and even more powerful crossbows. They created crossbow manuals, detailing their construction, maintenance, and tactical deployment. It was a core part of their military doctrine. So why did the crossbow eventually fade from the battlefield? The answer, as you might guess, is the rise of firearms. By the late Ming dynasty, cannons and early muskets started to appear. While these early firearms were clumsy, slow to reload, and inaccurate, they had one major advantage. They required far less training to use effectively. A peasant could be taught to use a musket relatively quickly, whereas becoming a proficient crossbowman took years of practice. As firearm technology improved, becoming more reliable and powerful, the crossbow's military role slowly diminished. It was gradually replaced, relegated to a hunting tool or a ceremonial weapon. But the legacy of the ancient Chinese crossbow lives on. It represents a pinnacle of ancient mechanical engineering and tactical thinking. It was a weapon that allowed strategy to triumph over brute force, a tool that empowered the common soldier and shaped the destiny of empires for millennia. From the intricate bronze triggers of the warring states to the rapid-fire ingenuity of the repeating crossbow, it stands as a powerful symbol of innovation. The next time you see a crossbow in a movie or a game, remember its incredible journey through history, a story of power, precision, and a weapon that truly changed the world. Thanks so much for watching. If you enjoyed this journey into ancient military tech, don't forget to hit that like button, subscribe, and ring the bell so you won't miss our next deep dive into history. See you in the next one. But there was a problem that plagued every crossbow designer. As you made the prod more powerful to increase range and penetration, it became harder to draw back the string. A prod that stored enough energy to punch through armor might require several hundred pounds of force to cock. No human arm could draw such a weapon by hand. The Chinese solved this through a series of ingenious cocking mechanisms that multiplied human strength through leverage and mechanical advantage. The simplest method, used on lighter crossbows, was the belt hook. A soldier would attach a hook to his belt, loop the string over it, then push down on the crossbow with his hands, while lifting with his legs and back. This allowed him to use the powerful muscles of his legs instead of just his arms, effectively multiplying his drawing strength. For more powerful crossbows, Chinese engineers developed the stirrup, a bronze or iron loop mounted on the front of the crossbow. The soldier would place his foot in this stirrup, pinning the weapon to the ground, then use both hands to draw the string back to the trigger mechanism. His entire body weight now contributed to cocking the weapon, allowing even relatively slight soldiers to span weapons with draw weights exceeding 300 pounds. But the true masterpiece of cocking technology was the goat's foot lever, a compound lever system that allowed soldiers to cock even the most powerful crossbows. This device consisted of a pair of hinged levers attached to the crossbow stock. The soldier would hook the levers onto the string, then squeeze the handles together. Through the principles of leverage, this action multiplied the soldier's strength by a factor of 5 or more, making it possible to cock crossbows with draw weights approaching 1,000 pounds. The heaviest Chinese crossbows, used for siege defense or hunting large animals, required windlass mechanisms, essentially a hand crank system with gears that could reduce the effective draw weight to manageable levels, though at the cost of much slower reload times. Picture now a battlefield in 260 BCE, during the massacre at Chengping, where the state of Qin annihilated a Zhao army of nearly 500,000 men. The Qin troops, many of them conscripted farmers who had been soldiers for only months, stood in dense ranks. In their hands were crossbows, weapons they had learned to operate with deadly efficiency in mere weeks of training. The Zhao warriors, veterans of countless campaigns, advanced with swords and spears, expecting the traditional clash of hand-to-hand combat. Instead, they met something unprecedented in the scale of warfare: massed crossbow fire. The Qin crossbowmen did not aim at individual targets. They could not. The distance was too great, the battlefield too chaotic. Instead, they aimed at areas, shooting in coordinated volleys that turned the sky black with bolts. Each soldier could lose 3 to 5 bolts per minute, depending on the complexity of his cocking mechanism. Multiply that by thousands of crossbowmen, and the result was a storm of bronze-tipped death that shredded the Zhao formations before they could close to melee range. The crossbow had done something that aristocratic warriors had thought impossible. It had made killing efficient, mechanical, impersonal. A farmer who had been plowing rice paddies 6 months earlier could now kill a warrior who had trained since childhood, and he could do it from 200 paces away. The bolts themselves were works of careful engineering. Unlike arrows, which needed to be light to fly from a bow drawn by human muscles, crossbow bolts could be heavier and shorter because they were propelled by mechanical rather than muscular force. A typical bolt was about 30 centimeters long, made from hardwood or bamboo, with 3 feather fletchings set at a slight angle to induce spin stabilization. The head was bronze or iron, shaped in various designs depending on the intended target. Against unarmored troops, a simple pointed head sufficed. Against armor, pyramid-shaped heads concentrated force on a tiny point, maximizing penetration. Some bolts featured barbed heads designed to stick in shields, making them unwieldy. Others had broad, razor-sharp heads for hunting or for causing maximum hemorrhaging in human targets. The crossbow's effective range varied dramatically based on its power and the type of bolt used. A light hunting crossbow might be accurate to 50 or 60 paces. A military crossbow, in the hands of a trained soldier, could hit man-sized targets at ranges up to 150 paces, with a maximum range shooting at an elevated angle that could exceed 300 paces. The most powerful crossbows, siege weapons mounted on walls or ships, could launch massive bolts that were more like short spears, capable of penetrating multiple ranks of soldiers or punching through wooden shields and light fortifications. But effective range meant little without accuracy, and here the crossbow revealed another of its mechanical advantages. The stock provided a stable platform that could be braced against the shoulder or chest. Simple sights typically, just a front post and a rear notch, gave soldiers a consistent aiming reference. Because the bolt sat in a groove along the top of the stock, it flew true without the need for complex release techniques. An archer must train for years to develop a smooth, consistent release that doesn't deflect the arrow. A crossbowman simply pulled the trigger. The mechanism handled the release with mechanical precision every single time. This reliability, this repeatability, was what made the crossbow the weapon of mass armies. The tactical implications rippled through Chinese military thought. Generals now had to account for an enemy that could inflict devastating casualties at ranges where traditional weapons were useless. Castle walls had to be built higher and thicker to keep defenders out of crossbow range. Siege tactics evolved to include massive shields called ox-hide screens that could protect soldiers from crossbow fire while they advanced. Armor became heavier, evolving from leather and layered cloth to iron plates and scale armor. The entire material culture of Chinese warfare was reshaped by this single innovation. Yet the crossbow was more than a military technology. It reshaped social structures and political power. In the earlier periods of Chinese history, warfare had been dominated by aristocratic chariot warriors and skilled archers who formed a hereditary military elite. These warriors spent their lives training in the martial arts, and their privileged position in society was justified by their irreplaceable military value. The crossbow destroyed this justification. If a peasant could be turned into an effective soldier in weeks rather than years, then military power no longer rested solely with the aristocratic class. The crossbow was, in a very real sense, a democratizing technology, though. Democratizing is perhaps the wrong word for a tool that made killing more efficient. It shifted military power toward states that could mobilize large populations and manufacture standardized weapons at scale. The state of Qin, which would eventually unify China under the first emperor, understood this better than any of its rivals. Qin's rise to dominance was built on several factors: ruthless legalist administration, efficient agriculture, strategic diplomacy, but also on its mastery of crossbow production and tactics. Archaeological excavations of Qin military sites reveal workshops capable of producing thousands of crossbow trigger mechanisms to standardized specifications. The terracotta warriors buried with the first emperor, those famous clay soldiers standing in eternal formation, originally held real weapons. Many held crossbows. Even in death, the first emperor wanted to be protected by the weapon that had won him the world. The engineering sophistication of these Qin-era crossbows cannot be overstated. When archaeologists excavated crossbow trigger mechanisms from tombs dating to the 3rd century BCE, they found bronze pieces with surface finishes smooth enough to reduce friction to minimal levels. The pivot pins showed signs of deliberate design choices. Some were chamfered to prevent binding. Others had slight grooves to hold lubricant. These were not happy accidents. They were the results of systematic experimentation and refinement, the products of what can only be described as an engineering tradition that valued precision and reliability. One particular find illustrates this perfectly. A crossbow trigger mechanism excavated from a Qin tomb still functioned when assembled by modern researchers, despite having been buried for over 2,000 years. The bronze had corroded, but the geometry was so precise that the mechanism still operated. Compare this to medieval European crossbows, which often relied on simpler triggers and cruder manufacturing. Chinese crossbow designers had achieved a level of mechanical sophistication that Europe would not match until the late Renaissance. The intellectual framework that made this possible was deeply rooted in Chinese philosophical and technical traditions. Mohist philosophers, followers of the teacher Mozi, who lived during the late spring and autumn period, were particularly concerned with military technology and fortification engineering. Mohist texts contain detailed discussions of siege warfare, defensive architecture, and weapon design. They approached warfare not as a glorious expression of martial valor, but as a technical problem requiring systematic solutions. The crossbow, with its emphasis on mechanical advantage over individual strength, on standardization over bespoke craftsmanship, embodies this Mohist approach to military technology. But there is a darker current running through this story, one that speaks to the double-edged nature of technological progress. The same mechanical precision that made the crossbow an engineering marvel also made it a tool of industrial-scale killing. When the Qin finally conquered the other 6 states and unified China, they did so through campaigns that killed millions. The crossbow, more than any other single weapon, made this level of carnage possible. It transformed warfare from a contest between trained warriors into something approaching the mechanical slaughter of modern warfare. Consider the psychological dimension. A soldier facing an enemy with a sword or spear confronts a human being, another person whose face he can see, whose fear he can sense. The intimacy of hand-to-hand combat, however brutal, maintains a certain human connection. But a crossbowman killing at 200 paces sees only targets. The distance, the mechanical nature of the weapon, creates a psychological separation between killer and killed. The crossbow anticipated, by 2,000 years, the industrial warfare of the 20th century, where soldiers kill people they never see, using machines that mediate and distance the act of killing. Yet we cannot end this exploration in darkness, because the crossbow also represents something profoundly human. Our endless ingenuity, our capacity to understand and manipulate the physical world, our drive to solve problems through careful observation and systematic thinking. The Chinese craftsmen who perfected the crossbow trigger mechanism were not fundamentally different from the engineers who design microprocessors today. They observed, they experimented, they refined. They passed knowledge from master to apprentice, building an intellectual tradition that stretched across generations. They took abstract principles, leverage, stored energy, mechanical advantage, and made them concrete, useful, real. The crossbow's influence extended far beyond China's borders. Through trade and conquest, the weapon spread to Korea, Vietnam, and eventually Japan. The Silk Road carried crossbows westward, where they influenced weapon development in Central Asia and the Middle East. When European crusaders encountered Eastern crossbows, they recognized a superior technology and adapted their own designs accordingly. The Chinese crossbow's trigger mechanism, in particular, influenced European weapon makers, though Europe would not achieve comparable precision in mass production until the advent of machine tools in the Industrial Revolution. Through the centuries that followed, as Chinese dynasties rose and fell, the crossbow remained a constant presence on the battlefield. The Han Dynasty, which followed the Qin and established one of China's greatest imperial ages, continued to rely heavily on crossbow-armed infantry. Han crossbows became even more sophisticated, with some featuring adjustable sights for different ranges and more refined trigger mechanisms with safety catches to prevent accidental discharge. The military manuals of the Han period contain detailed instructions for crossbow tactics, describing coordinated volley fire and combined arms operations that integrated crossbowmen with cavalry and infantry armed with traditional weapons. During the Three Kingdoms period, that tumultuous era romanticized in Chinese literature and folklore, the crossbow played a decisive role in numerous battles. The legendary strategist Zhu Liang supposedly invented a repeating crossbow called the Shu Kou Nu, though archaeological evidence suggests that repeating crossbows existed earlier. Regardless of its true origins, the repeating crossbow represented another leap in crossbow technology. A magazine that held multiple bolts. While these repeating crossbows sacrificed power and range for rate of fire, they offered devastating close-range firepower, particularly useful in naval battles or siege defense, where rapid fire mattered more than long-range accuracy. The Song dynasty, facing pressure from nomadic peoples to the north, invested heavily in crossbow technology. Song military arsenals produced crossbows on an unprecedented scale, with standardized parts that could be easily replaced. Some Song crossbows featured mechanical sights with multiple aiming points for different ranges, approaching the sophistication of modern rifle sights. The most powerful Song crossbows required teams of men to operate, using windlass cocking mechanisms and shooting massive bolts that were essentially short javelins. These weapons defended city walls and river fortifications, holding back invasions through the application of mechanical force multiplied by human ingenuity. But the crossbow's dominance could not last forever. The introduction of gunpowder weapons began to change the calculus of warfare. Early firearms were unreliable, inaccurate, and slow to load, but they offered something the crossbow could not match: the ability to penetrate any armor at any range, limited only by the amount of gunpowder available. As firearms technology improved through the Ming and Qing dynasties, the crossbow gradually faded from military use. By the time European colonialism reached its height in the 19th century, Chinese crossbows had become museum pieces, relics of an earlier age of warfare. Yet the engineering principles embedded in those ancient weapons did not fade. The understanding of springs and levers, of energy storage and release, of mechanical advantage and precision manufacturing, these concepts continued to evolve, eventually contributing to the industrial technologies that would transform human civilization. The same principles that Chinese craftsmen used to design crossbow trigger mechanisms would later be applied to clockwork mechanisms, to printing presses, to steam engines, to the countless mechanical devices that powered the Industrial Revolution. Today, we can use computer simulations and artificial intelligence to reconstruct how these ancient crossbows functioned, to model the stresses on each component, to calculate the precise trajectories of bolts in flight. We can analyze the metallurgy of bronze trigger mechanisms using spectroscopy and electron microscopy, revealing details about ancient manufacturing processes that would have amazed even the craftsmen who created them. We can 3D scan archaeological finds and create perfect digital replicas, then use those replicas to test how different design variations would have affected performance. This marriage of ancient technology and modern analysis reveals something profound. The engineers of ancient China were solving the same kinds of problems that engineers solve today: how to convert energy efficiently, how to minimize friction, and how to create mechanisms that are both powerful and reliable. The crossbow stands as a bridge between ages, a reminder that human ingenuity is not a modern invention. 2,000 years before computers, before electricity, before even the scientific method as we understand it, Chinese craftsmen created machines that embodied sophisticated engineering principles. They did so through careful observation of the natural world, through trial and error, through the patient accumulation of knowledge across generations. The bronze trigger mechanism with its precisely machined surfaces and clever interlocking parts represents the same impulse that drives engineers and scientists today, the desire to understand how the world works and to use that understanding to create something new. As Chun, our soldier from the opening of this story, releases his finger from the trigger and watches his bolt fly true across the battlefield, he is participating in a moment that transcends his individual experience. He is connected to the craftsmen who smelted the bronze for his trigger mechanism, to the foresters who selected the wood for his stock, to the Fletcher who carved his bolt, to the generals who devised his tactics, and to all the soldiers who will come after him, wielding weapons built on the same principles of leverage and stored energy, just expressed in different forms, from medieval arbalests to modern compound bows to artillery pieces that use explosive force instead of mechanical tension, but still rely on the same fundamental physics to project force across distance. The ancient Chinese crossbow was never just a weapon. It was a crystallization of knowledge, a physical manifestation of accumulated wisdom about materials mechanics and the natural world shaped into a form that could alter the course of human history. And perhaps that is the deepest lesson we can take from this remarkable technology, that our tools shape us as much as we shape them, that the choice to create something, whether a weapon or any other technology, sets in motion consequences that ripple far beyond the moment of invention, and that the same human cleverness that solves problems can create new and unexpected challenges that future generations must grapple with in turn. An endless cycle of innovation and adaptation that defines what it means to be human, bound neither by the limitations of our individual strength nor by the span of our individual lives, but connected across centuries by the knowledge we preserve and pass forward, building upon the foundations laid by those who came before, just as they built upon foundations older still, reaching back through the generations to the first moment when a human hand shaped a tool and realized that we could extend our capabilities beyond the limits of flesh and bone, that we could think our way past obstacles, that we could remake the world through the application of careful thought and patient craft, realization that has driven human civilization forward from the Stone Age to the Space Age. From the first chipped flint to the computer you're reading this on, an unbroken chain of innovation that runs through crossbow trigger mechanisms and encompasses everything we have built and everything we will build. A testament to the enduring power of human ingenuity to transform the possible into the real.